So I'm going to be doing this question here, which is essentially a trigonometric proof question. So we have to prove that this expression is precisely the same as saying this expression here. Okay, so now in trigonometric proofs, one of the first steps is trying to decide if we're going to take the left-hand side and manipulate it somehow to get the right-hand side, or if we're going to take the right-hand side and manipulate it somehow to get the left-hand side. And generally, when we're deciding this, we want to go from a more complex to a simpler form, because it's generally easier to simplify than it is to complicate things in the right way, if that makes sense. So let's consider the left-hand side, and so it looks like we've got some cotangents here. We've got a cotangent here, we've got a tangent here. On the right-hand side, we've got just our elementary sine and cosine functions. We've got this tan squared theta here, though. And so essentially, we can see that if we want to go from the left-hand side to the right-hand side, we're going to have to try and force a tan squared theta, or actually a tan to the power 4 theta, because, okay, hold on. If we want a tan squared theta to appear outside of the square root like this, essentially we want a tan to the power 4 theta inside of the square root, and because this implies this. And this is because, well, tan to the power 4 theta square rooted is equal to tan squared theta, obviously. So this is why this is true. And so, if we want to take the left-hand side and try and get the right-hand side, we're going to have to try and force a tan to the power 4 theta to appear inside here. But if we try and take the right-hand side and go to the left-hand side, then we're going to have to bring this inside, so bring a tan to the power 4 theta in here, and then simplify the inside of this so that we get this. So it's not immediately obvious which way is better. I'm just gonna go with the left-hand side and try and manipulate it to get the right-hand side, and if it doesn't end up being very nice, then we can try again and start with the right-hand side. Okay, so what actually is the left-hand side? Well, the left-hand side is equal to, well, it's just what we are given, which is, hold on, okay, which is tan to the theta plus sine theta over cot theta minus cos theta. Okay, immediately I don't like this cot and tan because they can obviously be rewritten in terms of more elementary trigonometric functions, and so that's what I'm going to do. So tan theta is equal to sine theta over cosine theta. We're going to keep this sine theta from above, and on the denominator of this fraction we have cotangent theta, which is precisely equal to cosine theta over sine theta, and then we have minus cosine theta here. Okay, and now one thing we can do is we can rewrite this section here as one fraction, and rewrite this section as one fraction as well. So we're going to try that. And so we're going to end up with here is sine theta times cosine theta all over cosine theta, and this entire thing is going to be over what we have here, and we're going to rewrite this as a single fraction as well. So we have cosine theta minus cosine theta times sine theta, which is this denominator here, all divided by sine theta. Okay, so let's see if there's anything we can do here, and yes there is. We've got the sine theta, which we can take as a factor out of this top bit, and we have cosine theta, which we can take as a factor out of this bit. So let's go ahead and do that before we proceed. So take the sine theta out, and then we have 1 plus cos theta remaining, and this was over cosine theta. And here we take the cosine theta as a factor. We have 1 minus sine theta all over sine theta. Okay, and now we can take this entire thing and make it into a single fraction as well. So, and the way I do this, well, we just have this sine theta 1 plus cosine theta here, and we have to multiply it by this denominator. So like that, all over, and then we have this multiplied by this. So cos theta 1 minus sine theta multiplied by cos theta. So this is interesting. So we've got sine theta, cosine theta, cosine theta. So we can obviously simplify this. 1 plus cos theta here, sine squared theta here, 1 minus sine theta, and times by cosine squared theta. And notice that this is just tangent squared theta, and so let me just write that step for you. So we have 1 plus cosine theta, 1 minus sine theta, times by tangent squared theta. And so we can actually take this tan squared theta and take it outside the square root. So let me just write that up here. So let me just take out the tan theta. And I'm liking this because remember we had a tan squared theta outside, and that's what we're trying to get to. So it looks like we are getting a little bit closer, which is good. And what we have left here is just this. And so we have to try and manipulate this to try and get to this expression here. And so let's see. So we have a denominator of 1 minus sine theta here, but we want to somehow get 1 minus cosine theta here. And I'm just going to ignore this tan theta for the moment, and how it's supposed to be a tan squared theta, because hopefully, as we try and manipulate this to try and become this, hopefully a tan theta is going to drop out somewhere. Or actually, I should say a tan squared theta is going to drop out somewhere. And so this is, I'm going to try and rewrite this. And I'm going to draw this a very long square root, and you'll see why in a bit. So I want 1 minus cos theta as the denominator, and I want 1 plus sine theta as the numerator. And I'm going to try and force that to happen. So first of all, let's just keep what we have already. So I'm just going to copy that, like so. And we want a denominator of 1 minus cos theta. So I'm going to times it with something which has a denominator of 1 minus cos theta, but obviously we can't just times it by anything here. This numerator also has to be 1 minus cos theta, because now we're essentially just multiplying by 1, and if we multiply any expression by 1, that's just going to be equal to that same expression. So we're not changing anything here, and that's good because we don't want to. And likewise, we want a numerator of 1 plus sine theta, so I'm going to multiply by 1 plus sine theta over 1 plus sine theta. And again, we're not changing anything here. So let me just rewrite this as a single fraction. So we have 1 plus cos theta, 1 minus cos theta. So that's interesting already, and you might be able to spot something already from that. And then we have this all over 1 minus sine theta, 1 minus cos theta, 1 plus sine theta. Okay, and you might notice something interesting about these terms as well. And obviously we can cut these out, we can cancel this, we can cancel this and this, but we don't want to do that, because then we'll be going back to this. And we introduced these specifically so that we could force them into it, so into the fraction, so cancelling it now would undo our work, essentially. But yes, I hinted earlier that there was something interesting about these terms here, and that is that they are a perfect square. So 1 plus cos theta times 1 minus cos theta can be written as 1 minus cos squared theta because it's a perfect square, and we have this 1 plus sine theta remaining. And this is also in a perfect square form, so we can write this as 1 minus sine squared theta, and we have 1 minus cos theta remaining. So I really like this development because essentially we've got sine squared theta here and we've got cos squared theta here, and so we've got tan squared theta here, which we can bring out, and we're pretty much done actually, and I'll show you what I mean. So we have the tan theta still there from before, and from our trigonometric identities we know that this is equal to sine squared theta, and we have this remaining, which is 1 plus sine theta, and we have this, which is 1 minus sine squared theta, which is just cos squared theta, and then we have 1 minus cos theta remaining. And so you may be able to see the answer from here now. So we have a tan squared theta right there, times by 1 plus sine theta, 1 minus cos theta. And if we see what we're trying to get, 1 plus sine theta, 1 minus cos theta, you can see this is perfect. And we've got a tan squared theta here, which we can take out and bring to the front, so multiply right here. So we actually have a tan squared theta at the front here. And inside the square root, we have 1 plus sine theta over 1 minus cosine theta, which is precisely our right-hand side. And so this is equal to the RHS. And so we have shown that the left-hand side is equal to the right-hand side. So LHS is equal to RHS. So we have proven the thing proved. Yay.